All right, we are recording, and here we go. Thank you for joining.
Hello everyone, welcome to my presentation on building custom forms in React using FHIR questionnaire and extensions. My name is Karl Purkhardt and I'm a UK-based lead front-end engineer at Northwell. I work on the Emerging Technology and Innovation team, where we research and develop a range of innovative products using emerging technologies. Today, we're going to look at how we've implemented FHIR-driven forms in React and some of the cool stuff you can do with this technology stack. We'll take a look at 3 different extension patterns that we use to improve our forms. But first, let's take a look at the technologies we use. At the bottom of our stack is FHIR. FHIR is the foundation of our forms. We model our forms using a FHIR questionnaire and capture responses using FHIR questionnaire responses. This FHIR data is managed in Google Cloud using the Cloud Healthcare API. On top of FHIR, we have a custom form renderer built in React. This form renderer parses the FHIR questionnaire definition and renders it on screen as a form. When users save the form renderer grabs the values entered by the user and packages them up as a questionnaire response. The next technology is Material UI. This is a React component library that provides prefabricated components that implement material design. Material design is the design language that we follow in our core product. So we leverage Material UI to create forms that match that style. Finally, we have adaptive cards. While this technology is not a core dependency of our form renderer, we use it to drive some interesting use cases that we're going to look at today. We're now going to look at some of the patterns that we use to extend FHIR questionnaires and provide additional value to our users. The first pattern allows us to render real-time information that helps our users when filling in forms. Powering this pattern is an external service that returns adaptive cards that can then be rendered on the form. This is a super powerful pattern because it allows us to enrich forms with useful information without any additional coding or deployments. The second pattern allows us to render any Material UI component on our forms. This allows us to level up the design and appearance of our forms, resulting in big improvements to user experience. Finally, the last pattern enables us to render embedded FHIR questionnaires. This allows us to compose forms by combining existing forms or to treat multiple forms as a single logical unit. This really demonstrates the power and flexibility of FHIR questionnaires and custom form renderers. Let's take a closer look at that first pattern, rendering real-time dynamic content using FHIR. Let's start by looking at one of the forms from our core product, the PX workflow form. PX stands for Patient Experience. I'm presenting this form as a wireframe here to keep things simple, but this is a real form used to manage real patients. We use this form to help manage the patient's experience to ensure that they receive the best experience we can provide. The first 2 sections on this form use this first pattern. They render dynamic content by calling an external API. Let's take a closer look at each section. The first section is called PX Opportunity. This section provides the user with up-to-date information on areas that might negatively impact the patient. The second section is the token history section. This section displays a history of previous tuck-ins. A tuck-in is basically a check-in with the patient with the goal of identifying any flags that could lead to a negative patient experience. Both sections are rendering real-time dynamic content by calling an external service to fetch adaptive cards. Let's take a closer look at each section. On the bottom of this slide, you can see a snippet of the FHIR questionnaire definition. In this snippet, you can see that we've used a custom extension object to describe the type of extension. In this case, an adaptive card, along with an ID of the card that we want to display. Behind the scenes, our form renderer knows how to handle this custom extension. When we render this section of the form, we'll first render it with a loading placeholder while the card is being fetched in the background. As soon as the card is ready, we'll switch out the placeholder with the card content returned from the API call. This is a powerful pattern and allows us to render real-time information on any of our forms. Another example of this pattern is the tuck-in history section. Looking at the form definition for this section, we can see the same custom extension object is used. We're using the adaptive card custom extension type again, but this time we're asking for the PX tuck-in history card to be returned rather than the PX opportunity card. This pattern allows us to build a library of adaptive cards that can then be fetched and rendered on forms at runtime. Cards are fetched via an API call, and a placeholder card is displayed while the fetch is in progress. We use a custom extension object on a questionnaire item resource to drive this pattern. Let's now look at the second extension pattern, rendering material UI components. Before we dive into this pattern, let's step back and discuss Material UI. Material UI is a React component library that implements Google's material design and offers a bunch of pre-built components that you can use to build user interfaces. There are high-level components such as dialogues, tables and lists, and there are lower-level components such as typography, buttons, text fields, and checkboxes. Each of these components can be configured and customized. You can see some examples of Material UI components at the bottom of this slide. We customize components using props. These are basically inputs to components that change the appearance and behavior. A good example of this is the button component, which has a prop called variant. This prop is used to change the overall style of a button. Here we can see some examples of how the variant prop changes the appearance of a button. So how do we drive this from FHIR? We use a custom extension object again. This is very similar to the first pattern. The main difference is the type. In the first pattern, we passed adaptive card for the type. In this pattern, we pass MUI component. You can see that we're also passing a name. This is the name of the component that we want to render. Finally, we can also pass some props. These props are forwarded to the Material UI component, allowing us to change the behavior and appearance. Let's take a look at some examples. On this slide, we can see the Material UI divider component. On the right side, you can see a form mockup that also features a divider. How can we achieve this with a FHIR-based form? It would be difficult to automate this because the placement of the divider can't be easily predicted. Let's take a closer look at how the second pattern achieves this. I've pulled out the options this time and placed them in a table so they're a little easier to read. We've discussed type already. It's always going to be MUI component for this second pattern. After type, we have name, which is the name of the component that we want to render. That's divider in this case. Finally, we have props. In this case, we're not passing any props because we don't want to modify the component. And that's all we need to do to render the Material UI divider component on our form. Here's another example of this pattern. In this example, we're rendering an alert component. Unlike the divider, the alert component can take some text which is rendered inside the alert. On the left side, we can see a few variations of the alert component. These variations are driven by a severity prop. On the right side is a mock-up showing what we want to achieve. We want to display an info alert with some text for the user. Let's see how we achieve this. Like the divider, we're using the MUI component type. We're passing alert for the name of the component, and we're also passing a prop called severity with the value of info. We can also see the text property has been used this time. This property is used to provide the text that is rendered inside the alert component. This pattern allows us to render any Material UI component on our forms. This is a super useful pattern for improving the design and ultimately the user experience of our forms. Like the first pattern, we used a custom extension object to drive this functionality. This last pattern clearly demonstrates the power of extending FHIR with a custom form renderer. This pattern is used to embed one or more questionnaires inside of another and allows for a few advanced use cases. The first use case is form composition. We can reuse common form sections in different forms. On this slide, we see two forms, a billing form on the left and a registration form on the right. Both forms share a common set of fields to capture the user's address. Rather than duplicate the form definition, we can create a reusable set of fields. This is the form in the center. We can then embed these fields into our billing and registration form. When the billing or registration form is submitted, we only create one questionnaire response. The values from the embedded form are merged with the parent form's values. The second use case is treating multiple forms as a single form. Instead of sharing a common set of fields, what if instead we want to embed one form inside of another, so that we can treat multiple forms as a single form? This allows us to present two forms as one, but save them both with a single button click. Here we have the PX workflow form again. This time we have some new fields in the center of the form to record a token. This whole section is a separate form which is embedded inside the parent form. When the user submits the parent form, two questionnaire responses are created. One to capture the values on the parent form, and another to capture the values on the embedded form. But how do we embed one form within another? How is this represented in the questionnaire definition? We achieve this using a reference type questionnaire item. When our form renderer encounters a reference to another form, we simply fetch that form and render it in place. We do this during the initial load of the form, ensuring that the whole form is presented to the user as a single unit. This pattern allows for some powerful and advanced use cases. By enabling forms to be composed, we allow sections of forms to be easily reused and for multiple forms to be treated as a single unit. Unlike the previous patterns that use custom extension objects, this pattern is driven by reference types. Today, we looked at a few different examples of how we can take advantage of FHIR's extensibility to create awesome forms. First, we looked at how we can render real-time dynamic content by calling an external service to fetch pre-populated adapted cards. Next, we looked at how we can leverage extensions to render Material UI components to help improve design and user experience. Finally, we looked at how we can support embedded forms using FHIR references. We set out looking for a solution that could be leveraged to build rich forms to address business needs. We ended up building a custom form renderer in React that allowed us to build forms that match our product design and provide a great user experience. By leveraging FHIR, we were able to develop a solution that is built on an established, trusted standard that is extendable and interoperable. So the next time you think of building forms, think of FHIR. Thanks for listening.
All right, that concludes the pre-recorded presentation. Karl, looks like we have a couple questions in Whova. Would you like me to read those? I can do that.
Yes, please, Eric.
Okay, sure. First one is from Gabrielle Hess. How do you handle material UI components that trigger an action, example buttons, and can you provide a callback function via the props in the extension? If so, are there any security concerns?
That's a great question. Thank you. Up to this point, we haven't actually implemented or rendered any Material UI components in our forms that have that sort of behavior. We've basically been rendering components that are used for presentation mainly, just to improve the design and user experience.
Okay, next question was from Elizabeth Shivers. Was there a reason you preferred the reference type instead of another extension to handle embedding?
So the reason we chose the reference type just felt a little bit more conventional. So rather than introducing yet another custom extension which would need to document, it just made more sense to rely on what was already there and provided to us by FHIR.
Okay. Next question is, does this approach not violate the separation of concerns since the rendering and form population data are separate means of workflows?
Could you repeat that, Eric, please?
Yeah, sure. Does this approach not violate the, quote, separation of concerns, quote, since the rendering and form population, the data, are separate means of workflows?
I'm not sure I'm following that question fully, to be honest.
It's questions from Kahit Atilgan. If you would like to unmute yourself to expand on that, you could.
Yes, I can do that. What I mean was, like, we're getting the data from the questionnaire and questionnaire response. At the same time, we're also handling the rendering. So would it be not nicer like to handle the data separately and do another call, or like separate the rendering with the client and not like doing it in the questionnaire response?
So in our implementation, we have separated all those concerns out. So we have our sort of rendering layer, which takes the questionnaire, which is the form definition, and it takes the questionnaire response separately, and it combines all those things together.
All right, next question is from Brian. Have you tackled any complex validations or pre-populations? And he's referring to, and also if you've tried out the enable when logic.
So we haven't implemented the enable when just yet, or any of the sort of complex validations, but we have implemented some basic initial sort of data values for form fields.
Okay. I think that's all the questions we've had so far. Oh, no, I got another one here. From Tom, do you support repeating sets of data like address 1, address 2, etc., that consist of multiple connected fields?
Yes, we do. And they were a real pain to implement.
All right. I think that's it for the, well, here we go. Here's another question from Omar. Do you use a library to help use FHIR as the data structure, not only in questionnaires, but in your entire app?
Yes, so we use TypeScript with React, and we use a TypeScript library to provide typings. So we have autocomplete and that TypeScript support.
Okay. All right, that looks like all the questions so far, unless anyone has another question. Okay, here we go. Eric just asked a question. Do you have a means to capture the dynamic content in the questionnaire response?
Could you elaborate on that, please, Eric?
Eric, if you would like, yeah, if you could unmute yourself, maybe.
Yeah, sure. I was thinking that it sounds like you're presenting dynamically fetched material or information, and that could have a meaning for the clinician looking at the response to see in what context did the patient provide the answer that they provided.
Yes, that makes perfect sense. Thank you for elaborating. No, we don't capture the dynamic rendered content.
All right, anyone else have a question? Okay. Oh, yep, it looks like we've answered all the questions so far here. Last chance for a question. Here we go. Here's another question from Aditya. Do you support nested questionnaire items?
I think I'd have to check the code base, to be honest. But I think we do support nesting down to 1 level. I don't think it's n levels deep. I think we did put a limit on that. But in all honesty, I'd have to review the code to answer that question.
Okay. All right. I think that should do it for us. No more questions. All the questions looks like they've been answered. One final question from Brian. Is this a closed source project?
Yes, it is. There might be opportunity to take it open source in the future, but that's not something we've discussed right now.
Okay. Well, thank you, Karl. Thank you for the great presentation. Thanks everyone for joining. That does it for all the questions and answers.
Thanks, Eric.
Thank you all. Thank you, Karl. Thanks.
Thanks, Al.